Hey everyone, this is Lakshmikant from KGP Talkie. Thank you guys for waiting. So I see a lot of you have already joined this live bootcamp course, and I see a couple of people are still trying to join. So while they will be joining, I'll be admitting them in the meeting, and in meantime we can continue our bootcamp. So this is going to be 2 hours bootcamp, and obviously it is not recorded. So the two-way communication can be done here, and you guys can ask the question in the through the messages, and whenever the right time comes in, while I'll be taking this boot camp, I'll be answering those questions. And after the boot camp, I mean around the 10 p.m., once we finish this, thereafter I can start taking the question as well. Okay, I mean the direct question as well. Apart from that, I see a lot of you already know about me. And for those who do not know about me, let me just tell you quickly. So myself is Lakshmikant Tiwari. Hi Ajam, thank you. So yeah, this KGP Talkie is my YouTube channel, which I started like maybe the 10 years back when I was in IIT Kharagpur. So the Kharagpur short name is actually the KGP. Somehow it started with that particular name. To be honest, I don't remember why exactly I chose the KGP there. So probably I was there. So, maybe I choose that name because of that. But obviously there was no, the intention. Thank you, Azam. Okay, so after that, what I did, I started my own startup, and then after 3 years, I sold that. Then I worked in industry for a few years, 6 to 7 years, and thereafter I worked with one private equity management company, European company, for a couple of years, where I built AI system for finance management and so. And thereafter, finally, I dedicated myself completely over the AI training, corporate AI training, and for the YouTube channels. So probably most of you might have been noticing recently that I'm quite active at the YouTube and also on my LinkedIn and the Twitter channel, where I keep posting latest update and I keep doing the benchmarking of the latest model. For example, recently the Qwen 3.8 was launched, so I did all the benchmarking of Qwen 3.8 with the Glimmer, with the Zima 4, with the Nemotron 3.5 Lightning model, and so on. Okay, having said that, now as I have given my, the overall background, so why I feel that I'm the suitable person to teach the finance RAG, because I have built, the multiple the production grade AI system previously in the industry, where I have deployed these the solutions, and they are still working. So today, whatever we'll be talking here throughout this bootcamp, I'll be talking the production grade practices, generally what we do in the production, how do we handle the the large data and the complex data when we are discussing about the RAG. So RAG is like it has been in the market like 4 to 5 years. Before that, there was no term like the RAG. Yeah, thank you, Subramaniam. And there was no RAG like that, but the concept of RAG was already there. So you see, the RAG means retrieve, augment, and generate. If you just see that, it is just the short form of the retrieval augmented generation. But if you just break it down into a multiple part, so basically we are talking about the retrieve. Retrieve means actually the search, augment, and the generate part. So before the RAG, formally we have already seen the retrieval part. Okay. So retrieval has been in the market since many years. In fact, I would say that since decade. So retrieval means searching. You have a Google search, you have a e-commerce company search where, for example, you have the Amazon or the Flipkart. So their search is being done, right? So those search are actually the retrieval. So where this RAG came? After the retrieval, earlier what used to do, actually we used to do after retrieval part, whatever data was there was no modification on those data, right? So those data were being presented directly to the user without any kind of synthesis. So if you do synthesis over the retrieved data, whatever the search data came out of the system, then if you do the synthesis on that part, then it becomes the RAG. So this term come from there itself. So you can say that it is like the extended version of the search system which used to be there. So after the search, then we got there the augmentation and then the generation part. So when we talk about the augmentation part, that means we have the context which is coming after the searching, and then we have also the user query together. We are mixing those together, and then finally our LLM, large language model, is doing the final generation. So this is the overall concept and idea behind this RAG, how the RAG came. Now let me just bust some myth about the RAG. Like the RAG is not like which is being used in just some hi-fi system. So RAG can be used as simple as in any, I would say that RAG can be used in any chatbot as well. So if you see any chatbot which is working, so chatbot, you can also see that those chatbots are also the RAG system. Okay, great. Just a second. So those chatbots are also the RAG system. Okay, for example, let me just quickly show you here the Amazon, the chatbot. So you will notice here. So what you are currently seeing here, this Rufus.ai, this is the Amazon chatbot. So how many of you already know that the chatbot is itself a RAG system? If you do not know, let me just quickly tell you why this is the RAG system itself. So as I told you earlier, the RAG means retrieval, augment, and then generation part. So this AI system, what you are currently seeing, this chatbot is doing exactly the same thing. Okay. So even if you are trying to build a chatbot for some company, that chatbot is also considered the RAG system. I asked here a simple question. Thereafter, it has started giving me, let me just ask here some suggestions. Okay. Here, cricket batting tees on the Amazon. So I have asked here about the, the suggestions on the given product, whatever products are available here at the Amazon. So it has started giving me here the answer. So you see here how this overall thing is working. Let me just see. Seems like a lot of people are still trying to join. And I guess I'm not able to take them in the meeting. Yes. Okay, great. So let me just tell you how this is happening. So as I told you in the RAG, what is happening here? So RAG means so it is going to be the retrieval augmented generation part. And if I explain you through the concept how this overall thing works here, so you have the Amazon database, that is, let's say the DB, where you have all the products in the Amazon. Okay. So whenever a user comes in and asks a question, then there is the LLM which is connected with the database. It goes to the database and find out some relevant products which is related to my question. Thereafter, what happened here? Then it takes the user question and whatever the context is coming from the Amazon. Thereafter, it is mixing everything together. Basically, it is trying to generate the answer. Thereafter, finally, what it is telling here, then finally, it is going to give you the answer. So what we had seen previously, just that is actually the answer coming there. Okay. So let me just quickly show you that part again. Okay. So whatever thing you are currently seeing here, they are actually the answer. Okay. Great. So now the concept of the RAG, I hope the very much clear to everyone. Apart from that, one thing I should also tell you guys, because I did not talk about the LLM. So LLM is like nowadays everyone knows about that. The people who do not know about the LLM, I mean, I'm sorry to say that. I mean, they are actually, the quite far behind nowadays. So the AI is like out of 10%, almost the 9% are gonna lose the job in next 4 years. But those people are going to preserve this job who can learn how to use the AI. The people who cannot learn how to use the AI, they are definitely going to be irrelevant in next 4 years. So this is something which we have to keep in our mind while we are learning the AI part. Apart from that, I can just give you a scenario. when in early 1990, when computer came, at that time, people who learned how to use the computer, they became really very successful people. All right. And those who did not learn, and those who actually opposed, or those who were waiting for the like bubble, or the IT bubble or something like that, they actually they left behind. So similar thing is happening nowadays. There are so many people, or the conspiracy theory is there that the AI is bubbles. So believe me, AI is definitely not a bubble. In last 4 years, everyone have seen this. AI is definitely not a bubble. Although people do resist the change, but AI is something which is definitely going to change the world. So you can consider this AI is like that only. Okay, having said that, let's go ahead and get started with our bootcamp finally. What we are going to learn in this bootcamp, everything we are going to set here. Okay, so as I told you here about the RAG system, what is going to be important, the most important thing about the RAG, the retrieval part. And apart from that, the most of you have heard so many times previously that there is a problem with the system, AI system, any kind of AI system. That problem is the hallucination. Nowadays, we don't get that much of the hallucination on simple problem statements. But if you really give a complex problem statements to the small language model, which is known as the SLM, they really gets hallucinated. Okay. So why this hallucination comes? Because sometimes what happen, LLM is fine-tuned or trained on a particular set of the data, and we are asking question unrelated to that. Or we ask some tricky question which LLM cannot understand, because anyway, it's not a human brain. It is something which is actually trained on a particular set of the data. And that data is stored in its parametric memory. The parametric memory means this LLM model weights. This is where that overall weights are, overall memory of the LLM is actually stored. So what I want to tell you here, that the most important thing in any RAG system is the ingestion part, what you see here. So hypothetically, just assume if you have ingested wrong data in a vector database, let's say in the database, if you have ingested the wrong data in the database itself, then obviously you are going to get the wrong answer. Why the wrong answer? Because anyway, whatever chunks are going to be retrieved from the vector database, that is going to be definitely wrong. So the most important part in any RAG system design is going to be the ingestion pipeline itself. If you have a very strong ingestion pipeline, a very strong and reliable ingestion pipeline, then you are going to avoid any kind of hallucination while it is trying to generate your final answer. Okay, so now let me just hold on a second. Okay, so here you have your input side, you have ingestion pipeline, and so somehow I'm not able to write on the screen, guys. Just wait a minute. Let me just see that how I can close this. Yeah. Okay, so what I was trying to tell you here, that this is going to be the most important part here. Okay, so ingestion pipeline is the most important part. Why? Because until and unless you ingest the correct data in the vector database, it is not going to give you the correct output. As I told you earlier, in the RAG, you have the retrieval part, you have augmented part, you have the generation part. Retrieval can happen only when you have actually ingested correct data and in the correct format. So anyway, before you start working with the RAG, you have to do the ingestion. So this is something where people actually make the most of the mistake. While ingesting the data, they do not realize that how they need to chunk their document, how they need to ingest their data inside the vector DB. So this kind of the problem happens for the beginners who do not understand this. Okay, so this is something which we are going to which we are going to understand here. So how we need to do ingestion part correctly. Okay, so before we start the ingestion, first question comes in here, why you cannot ingest the whole document? Why you cannot ingest just the whole document? Why do you need the splitting here? What you see here, text splitting. Why do you need the chunking? Why you just cannot ingest all document inside this vector database, and then whatever query comes in, and then you can just simply find out that document and then answer the result, answer the question. Okay, so I can just give you the analogy to you. Suppose that you are giving an open book exam. So open book exam means you are giving exam, but you are also allowed to take the book as per your preference. So suppose that you are giving open book exam and you are given just one book to write the answer. But what happened? Let's say, some professor comes in and the professor decides, okay, I want to give you the 100 books. Okay. So if you are going to get the 100 book and if you are going to have just one book to answer, so which one you are going to prefer? Obviously, your answer is going to be correct if you have a one book. And even better than that, if you are going to get the exactly the same chapter, which from which this question has came, if you just get same chapter, then that is going to be the best for you. So the analogy is like that only. Because of that, you cannot actually put all, whole document inside the vector DB. What you have to do, you have to actually break it down. Like we discussed here, you have to break it down chapter wise. Similarly, you have to break it down into the chunks. So once you break it down into the chunks, then whenever user question comes in, then the relevant chunks can be retrieved from the vector database, what you are currently seeing here from here. Okay, cool. Now let me just show you here an example for a very large data set. So since this is a finance RAG, so we are taking here the financial data and we are taking the data from Securities and Exchange Commission. For the people who do not know about the finance data, for this kind of the data, let me tell you. So this is the Securities and Exchange Commission is like, the body in the US who overlooks after all these, the stock related companies and their financial other stuffs there. So basically all the companies which are actually, listed in the stock market there in the US, they are bound to file their financial, the informations and all the industrial, their activities to the SEC. So like you have the Amazon, Google, Apple, Netflix, every company, whatever listed company is there, everyone, every company is bounded to file their financial informations there. So there are multiple kind of filings there. Yearly filing is there, quarterly filing is there also. And also if there any sudden activity comes in, they also file that also. So the name of those files are like Form 10K, 10Q and 8K and so. Okay. So 8K is like they use it for the quarterly filing. So for quarter result, you might have heard about some company, let's say XYZ company has released the quarter result or the annual result, the financial result. So they are released in this particular form 10K or Form 8K. So there they have all information related to their financial status and financial activity, everything. Okay. And apart from that, for Indian, the audience, so in India, we have NSE and the BSE, and in other countries, they have also their, the own stock markets. I do not know for many other countries what is name of their. Probably in the Japan, we have a Nikkei, I guess, and then we have some Shanghai exchange, stock exchange, and so on. So similar to that, every country have their own stock exchange, and all these companies are actually bound to file these information in their stock exchange. Okay, thank you, Subramanya. Okay, so as you scroll it down, you are going to see here a lot of the data here. Okay, so this data is really very dense data. If someone comes to you, suppose that you are just, the intern, or let's say a fresher who has just joined the company, and someone just comes to you and ask that, hey, what was the P&L of the Amazon? Okay, and can you just give me some justification that how this P&L came, why, if it is up, then why up, if it is down, then why down, and can you just compare it with the Google as well, for example, for this one. Okay, I'm talking about without using the RAG system or without using the LLM. In that case, it is really going to take a lot of time for you to understand what is the current status of the PNL, why it is up or down, what have been other instances. What are other factors which is actually affecting it, and then comparing it with the Google as well. So it is really a very difficult process, and also it is error prone process as well. So people do make the mistake, like AI makes mistake. Okay, so people also do make the mistake as well. Since as you see here, this overall document is really a very dense document, a lot of informations you have. As you scroll it down, you are also going to see here the tabular information as well here. So this is related to the properties here, whatever facilities they have here currently, like office space, physical stores, fulfillment centers, and so on, and where they have here all these informations, right? They have here. Okay, so as you scroll it down here, they have started here the cash flows here as well. In the million it is represented. So you see all these informations are given here, but if you go through with these information manually, then it really becomes very difficult to understand on given if you have a multi-year data and also the multi-company data as well. Because of that, you need here some AI system to extract the relevant information and to compare those relevant information. Apart from that, let me just tell you here. So overall, the page number, if you notice here, it is 89 page. Okay, so 89 page is really huge. And if you notice here for the Google one, then you are going to notice it has almost 108 pages. 108 page and 89 page, it is almost 197 pages probably total. Okay. Suvek saying, sorry, I can't do that. Actually, we have here the, the worldwide audience as well. I do see here, we have a lot of Indians as well, but from other countries also, a lot of people have joined from US and European countries as well. Okay. So as I was talking about here, it is really very dense data, and a lot of data is here. So what we are going to do here, we are going to build our system here. Okay. Hi guys, thank you for joining from there. Okay, so we have here a pipeline. This is something is very important in the RAG system. Okay, so ingestion time. So before we start with the RAG system, it is really must to start with the RAG part as we discussed. Now, apart from that, few more things you are going to notice here. First of all, you notice something, this one. So again, this is something which people actually ignore when they are building the production grade RAG. Why I'm talking here the production grade RAG? Because see, RAG nowadays anyone can build. What you have to do, you have to just, get on the ChatGPT or the Cloud Code or whatever coding tool you are using currently. You just need to get on that coding agent and just write that you want to implement the RAG. Okay, see where you can beat other people. Okay, so nowadays AI assisted coding is being done in almost every company. Everyone is using AI assisted coding. So where you can beat other people, you can beat other people if you already know that what you need to do. Okay, so business concepts and the logics you have to prepare by yourselves. Now coders are not required anymore. If you are just good in the coding, then you are not required by the company. So you are required for what? For critical thinking, for business logics, and so for understanding the system, what you need, how you need to build. Because a system can be built in 1,000 ways. And if you just give that system, if you just give your prompt to the RAG, then not the RAG. If you just give that prompt to your, the coding agent, your coding agent is going to build the system for you. But it can build it in 1,000 ways. So what you have to do here, you have to make sure you tell your agent or the coding agent that how your coding agent need to make it. So again, until and unless you know how it need to make, your coding agent cannot know that how it need to be made. Okay. So what you have to do here, you have to make sure you deduplicate as well. Why? Because see, if you are making a production grade RAG, then you are going to get like thousands of the document and probably the millions of the document. Okay. So those documents are really very large. for me, when I was working in my previous company, we used to, they handle the millions of the document. At that time, when you have a very large set, so there is a very high chance that you are going to get the duplicate documents as well. All right, with a different name. For example, if you notice here, currently I'm having the name of my document Google 10K 2024. Someone might be sending you the same document with a different name, let's say with the copy, with the one or some other name. So in that case, what happened here? In that case, what happened here actually, if you have this deduplication, then it can identify duplicated document in the runtime, and it can then remove those duplicate in JSON so that you can avoid these duplicate in JSON. So the duplicate ingestion can be avoided on the 2 level. Okay. So let me just tell you on 2 level how this is going to be avoided. For example, you have here a very large file. Okay. And now you have this large file with the name of F1, and the same file you are going to have with the name of the F2. Okay. Now it is going to be the same file, but their hash value. All right. So their hash value is going to be the same. So whatever number you are going to get here, XYZ, etc. So alphanumeric value, they are going to be exactly the same for both of these files. So it is going to be ignored anyway. That is one case, how you do their deduplication on a file level. Apart from that, if you break it down into a multiple chunks, then there could be a scenario where file is different. I mean, where overall content seems to be different for the file, but inside the file itself, you have a same content for, let's say, the couple of pages or for many pages. Someone, let's say someone, what they did actually, they actually combined the same file into 2 times in a single PDF. Now, if you compare the file content hash value is going to be changed. Why? Because first file is going to have just 1 replicate, and the second file is going to have the 2 replicate. In that way, you will notice they are going to be the different. There is going to be the 2 different hash, but actually the content is same. Only the content is getting repeated 2 times. So on top of that, what we do here, we actually apply the hash value. So hashing on the chunk level as well. So all the chunks which you are currently seeing here, their hash value is also created so that we can actually avoid runtime, the runtime duplications, so that we can avoid those duplication part here. So similar thing happens here. So we calculate the hash value. If the page content is exactly the same, byte identical, then in that case, they are going to be the same. So it is going to reject the second hash. It is going to reject the second ingestion part. So this is really very important concept if you are building the production grade RAG system. Apart from that, the another important concept you are currently noticing here, that is going to be markdown loader. Okay. So before I move ahead to the markdown loader, let me just tell you here why we need these things here. So see, any machine system, like any machine, so they can work with the digital numbers only, like the binary numbers. So for us as a human, what we do here, we can read only the text data. Okay. If you try to read any MP4 or MP3 or maybe the PDF in its encoded form, then probably you will not be able to read those. So we will be able to read those only when they are written in actually the UTF-8 encoded form, or you can say the text format. Okay. So mostly all LLMs are actually the text LLM. So most of the data are actually used as the text input. Okay. So our LLMs are good to understand the textual data because overall their trainings are done on the text data. So whatever file we have here, all those files are going to need here. What they are going to need? They are going to need the text data. Okay. Now you can have the PDF data. You can have the XLSX and generally you also have the PPT data as well. All right. And sometimes you can have the HTML data as well. All these data need to be converted as the text data. Okay. So to convert all these data into the text data, there are many libraries. We have a PyPDF2 library. Okay, a PDF miner and so they are able to convert these PDF into the text format. Apart from that, you have many other libraries which can actually convert these XLSX PPT individually. But if we talk about as a whole, then we have two major library. One is the markdown, this one. The another library we have that is going to be the dockling here. Okay. Hi Kshitij, yeah, thank you. Please keep asking the question once I finish a particular topic, and then I'll just take that question and then I'll answer you. Let me just complete this explanation while I'm in the middle of this. Okay, so these are the two things here. We have here the markdown we have and the dockling we have. How many of you heard about the dockling? And how many of you think that I should be using here the dockling, not the markdown? Just, give me the thumbs up the people who have heard about the dockling part here. Okay. Yeah, I see a lot of you have heard about the dockling. Yeah, very nice. So I hope a lot of you have also heard about the market down as well. Yes, the dockling is from the IBM and the market down from the Microsoft. So you can ask here the question, I was talking about the production grade RAG, then why I'm not using here the dockling? Although the dockling is the most accurate library here. If we talk about from the accuracy perspective, yes, the llama parse and the light parse is also there. Okay, great. So why we are not talking about the dockling? Because you see, dockling is the costly one. The costly in the sense I'm saying here, it's a compute costly actually. All right, so it's a compute costly. That means it actually takes a lot of time. Until and unless you have a GPU to use the dockling library, it really becomes very difficult to work with the dockling. Where you have a millions of the document, then in that case, dockling really becomes very slow. Otherwise, it is going to be very costly. Why? Because you have to have there multiple GPU systems and every GPU system is working parallelly. Because of that, using a dockling really becomes very difficult. But for testing where accuracy is a paramount for you, there you must use the dockling. Otherwise, if accuracy is fine, that is not the paramount requirement apart from everything else, then I would say that you can go ahead with the market down part. And I see here some people say that they are also using the llama parse and other. Yes, definitely there are so many actually. Okay. Okay, cool. So now it is very much clear that how we convert our document into the text format. So we are going to use here markdown. All of these are going to support the multiple documents together. So basically, if you have a PDF, XLSX, PPT, HTML, all these can be converted in one go. Now the next part comes here, the splitter part. So once you have your text data, let's say you have your text data, something like this, very large text data. Generally, we store our text data as a .md file or .txt file. Mostly we store it as .md file. And this time we have here a very large set. As we discussed earlier, we have 89 pages content total. Okay, so this is going to be very large data. So if I say very large, in what context I'm saying very large, this is something which you really need to understand, and you need to understand it very carefully. There has to be some base. When I tell that it is very large, then how it is large, I need to define this. So in the definition, if I say it is very large, let me just give you here the approximation that how it works actually. So generally in a financial document, what happened here, one page content is going to have approx less than 1k tokens. Okay, so I'm saying here less than 1k token. Why? Because I have seen in my practice, generally it is 300 to 800 tokens. Okay, around 300 to 800 token. If page is really very dense, then it goes around 800. I'm just taking here a little bit, a little bit, the additional, the margin to make sure that I do not overflow. Okay, so I just need to admit a lot of people are still joining. Okay, no issue. So what we need to do here, we need to make sure, yeah. So there are 300 to 800, almost the tokens are going to be the per page tokens. Okay. So what we have to do here, if we have 89 pages, that means if we take here the max tokens, then it is going to be almost how much? It is going to be almost 89k tokens. Okay, so 89,000 tokens. Nowadays, what happened? We have heard about a lot of LLMs are coming with the context window of the 1 million. Okay, and they are also going to charge us as per the context utilization. Okay, so as per the context utilization, they are going to charge us. But again, the question comes in here that how do we decide how much context we need to keep here? So first of all, you need to understand here this. If I say it is going to be the 100k token, then I can say here almost the 10% is going to be filled by the context itself. That means whatever price is there, the 10% price is going to be, the 10% price is going to be, the occurred beforehand, before you start getting the answer. Apart from that, there are many other, the major problem with the context filling. So let me just show you here a proper, the window here with the proper diagram that what problem happened with the large context. Okay, so even though if your LLM model is going to have 1 million context window, that does not mean that you can get the high accuracy even if you fill this 1 million context window. Okay, why that is wrong actually? So as context window increases, let's say this is 1 million total context, I'm saying here this is context. So it is known as context increases, then model performance starts decreasing. So if I say here, this is a performance. Okay. So model performance starts decreasing as context window increases. Apart from that, as context window increases, the cost is also going up here. Okay. So this you see here, the cost is also going up without need basically. You see, even if you just need to ask a simple PNL, even in that case, you are just sending 89,000 tokens, or I would say that around 10% tokens you are sending just to ask the PNL. That means cost is also going up as the context is increasing. Apart from that, as context increases, speed also decreases. Okay, so this one I'm going to say here, this is speed. Okay, so model speed also decreases as context is increasing. I can give the same analogy like I told you when we started this course. At that time, I told you if you are given a full book where you have a tens chapter, let's say, or hundreds of the chapter, versus you are given just exactly the same chapter from where that question is asked. So you are going to perform better if you are directly given that same question. Okay, if you are given everything together in one go, then your answer is not going to be accurate. So I mean, you will struggle to answer basically. Okay. So, so with this concept, you can think that sometimes you might have noticed that while you are working with the chat GPT, while you are working with the Gemini model, when you start chatting with those models, they actually gives you better accuracy at the start of the chat. But if you just keep chatting after a couple of chats or 5 or 10 chat, you start feeling that their performance has decreased. You know, how many of you have felt this one before? Before I tell this one, before I told you guys this one, how many of you have felt this same issue? Okay, I see a lot of you have felt the same issue, right? So as this context increases, the performance actually decreases because of that. So it is not just like the theoretical concept. So previously what I have done actually, if you come here on the kgptalkie.com website, so here in the generative AI and here the Llama tools, here actually I have tested all these in the detail here. Okay, so I have shown these on record when I did a complete benchmarking of these models locally on my RTX 5090 GPU. Okay, so I did this benchmarking locally. Thereafter, I had seen here, let me just quickly show you how this has actually happened when I increase the context window. Let me just find out where is that particular part. Okay, guys, hold on. This is the category breakdown, each model cost to run. Okay, seems like I'm not able to find out that part. Or maybe I might have done in other article. Okay, so seems like it is somewhere buried in these article. I just need to find out this one. The context window, here it is. I have this one. Okay, so seems like somehow I'm missing in which particular article I have actually described this part. Probably this one. Yeah, so speed I also can show you here. Okay, so here as you see here, as context window actually increases, the speed also got decreased. Apart from that, in some article I have also shown that how increasing the context window actually decreases the quality, and in practice all of you have also seen that as well. Okay, so as we increase this where I was explaining you guys, I guess this one. Okay, so as I was explaining you here that as we increase this, okay, so as we increase the context window, then speed also gets decreased, cost is obviously going up, and the performance also decreases. Why this happens actually? Apart from that, one more thing actually happens. Um, the memory usage of the GPU also increases. So you can say that this is the KV cache. Okay, a lot of things actually happens with the context window. It's not very simple task actually. Understanding how this context affects overall stuff, that is also really the very important to understand. You see, a lot of things are going up here basically, and also a lot of things are going down here. Okay, like speed and the performance is going down, whereas the cost and overall GPU memory usage is going up. So this is the reason why companies are actually not releasing models with the 10 millions or billions of the token context window. It's not really easy. Apart from that, one more thing I should tell you here. You might have heard about a lot of models are getting released with the 128k tokens. Okay, or a lot of models are recently got released with 264k tokens, or you can ideally say the 256k token. All right, so why they are doing that? Because anyway they know that the people are not going to fill this 1 million token until and unless their models are that much accurate. For example, let's say if we are talking about the Fable 5, the most advanced model till now, so even the Fable 5, if you fill like 10 to 20% of the context, even after that it starts behaving something else, like its performance gets decreased as low as the Opus model. And if you just keep filling like half of the context window of these models, then they starts behaving like the Sonnet model. Because of that, we need here a smaller chunks. Okay, so we need to break it down into the smaller chunks here. So what you are currently seeing here, they are going to be the here chunks. Okay, now how we are going to decide there what is going to be the size of chunks? So ideally the size of chunks is going to be the less than 2k tokens. Okay, so the one thing you have seen here, a page is going to have a maximum 1000 token. Ideal page, not a very wide or without any margin page, might have a more data. But ideally the data which we are dealing here with the sec filing data, they are going to have less than 1000 token in one page. So your chunk size should be 2k tokens. Okay, I mean less than 2k tokens, not the 2000 tokens, but less than. Generally what we can do here, so in the best practice we can keep it in between let's say the 1k or so. Here it says the 10k, but actually ideally it should be the 1k, and the overlap should be the 0.2k actually. Okay, or but around the 20%. Okay, so apart from that, what you can also do here in our case, when we are dealing with the financial data, so instead of chunking it on the token wise, what we can do here, we can actually chunk this overall data the page wise. Okay, so if you see here the page wise data, so overall, the problem comes when you are actually dividing a context into a different page. I mean, into the different chunks. A same context got divided into a different chunk. That is the problem only. But generally in this financial data, you will notice a similar context is going to be in a same page. And the most important part which you need to handle here, that is actually the table. So table is something which really creates a problem if you break it down from the middle. So some part of the table goes in one chunk and some part of the table goes into the another chunk. But if you do it, the page wise chunking here, if you do here the page wise chunking, then you are going to preserve the table structure. Okay, so it is not going to create any problem. So you see this one balance sheet is going to be in one page, and then the consolidated income statement is going to be one page, comprehensive income is going to be the another page. Basically they are the standalone table. Okay, so they are not running into the multiple pages. So this is something which I want to tell you here. This is how you can actually break it down into the the chunks. So here we are going to do the page wise breaking system. Okay, so basically the chunking which we are going to do here, we are going to do here the page wise chunking. Okay, so now I hope this concept is also clear to you, that what we are going to do here. Okay, so we are going to do here the page wise chunking. So what you see here, these chunks, what you are seeing here, they are going to be the page wise chunking. So each page are going to be a single chunk data. Now let me just show you how that chunking and everything else is working here. Okay, so if you do the page wise chunking, let me just quickly show you here the sneak peek. Later on I'll explain you about this vector DB as well. So here we are going to see the finance RAG bootcamp, the collection, and there you are going to have here the full page content here. What you are seeing here, this is full page content here. Everything is going to be here. Okay, and apart from that, you notice here everything is actually ingested here as the text data without any markdown preservation. Nowadays LLMs are so strong that they can work directly with the text data without any the markdown structure. That is why generally now I do not use the docling. I have also developed the production grid system previously in the many the companies when I was working as working as employee there. So what I do here, actually I break it down page wise. Thereafter you also see here the metadata. Okay, so this is something which I'll explain you why do you need this metadata. So the metadata is also going to be super important part here. Okay, cool. Let's come back here. And apart from that, we will come to the quadrant part. Don't worry about that. So here, as I tell you here, oh, a lot of screenshots are getting taken automatically. Okay, so we do here the page wise chunking. Okay, that is clear. Now another important part comes in here, that is going to be the metadata extraction part. Now the question comes in here, why do we need the metadata extraction part? So this concept is very important. When I'll be taking you through the code, at that time I'll explain you. But on outer level, I can tell you why this metadata extraction is important. How many of you have heard about this? Basically, the filtering is also important in the RAG system. Okay, yeah, a lot of you have heard about this, right? So, okay, why filtering is important? Because you see what happened if you are just going to do the similarity match between the sentences or the words, then you are definitely going to get some similarity. That is 100% sure. For example, even if we do not have our, let's say the Apple related data, Apple company data, and we ask about the Google revenue, if you do not have a filtering, then it is just going to give you, it is just going to, give you some sample. So as an analogy, you can understand like this. For example, you are given various, balls with a different color. Let's say red, green, and the blue color balls. You have in a box, and you are asked about the pick a ball. Okay, just pick a ball without any kind of specification. You are just going to you are just going to pick a ball. All right. But if you are told that, okay, pick a red ball. So red means you are going to first filter out. You are just going to see here. Okay. So you are just going to filter out their, only those red balls, and then you are going to pick one red ball. Similar to that here, what I'm explaining you that if you have stored the relevant metadata, for example, company metadata, year metadata, what kind of data is stored there, if those kind of metadata, if you have stored chunk wise, then when you are going to do the retrieval part, at that time you can actually filter out the relevant chunk, and thereafter you can do the matching, and thereafter you can do the final synthesis part. If you follow these steps, thereafter I'm 100% sure your RAG system is not going to be hallucinated. But if you skip this filtering part, then it's very much guaranteed that your RAG is going to suffer with the hallucination, or it is not going to give you the accurate result. So this is something which you have to take care. All right. Okay. So these parts are now, I hope it is clear. I see here a lot of you have asked, the question in the discussion part. Yeah, thank you so much for that. Let me just take here some question if there is, and then I can get started with the coding part, and then I'll explain you other stuffs here. Okay. Thank you everyone who have joined my Udemy and YouTube and other stuffs here. Talking from IBM. Yeah, it is such an important session. Can we get the recorded session after this call? Yeah, Srikar. Yeah, I'll be sending, in fact, all the, the details after the call as well. So don't worry about that. You will be getting all the presentations, whatever I'm making here, everything here. Okay. So you see, I have here this presentation. So this I'll be also sharing with you guys, and everything you will be getting. Don't worry about that. So the basic concept and the fundamental is now, I hope, is very much clear. Apart from that, let me just quickly tell you one thing here. So this presentation which you are currently seeing, in previous session, actually, in previous session, a lot of you had actually asked me that what kind of a coding tool I use here. So, there are so many coding tool available in the market. You have a Cloud Code, you have a, the OpenAI Codex, you have a Gemini Anti-Gravity. Now everyone knows that, right? So these coding agent. But if you see the cost wise, so they are really very costly. And I have seen the accuracy of the anti-gravity is also not that much. But if you talk about the Cloud Code or the OpenAI Codex one, so their cost is really very high, like a $20, I guess, per month. Although some people can manage that, the $20, even after that, their usage limit. You just start doing some work, but after some time, what happened? They're actually, their token limits are exceeded. So basically, you are just logged out for 5 hours, something like that. So those who have been asking about that, which particular coding tool I use, let me just quickly show you here. So actually, I use the Minimax actually. So this is very good actually, the coding agent. So I use the Minimax coding agent for preparing all of the document, the presentation which you see here currently, the presentation which you are seeing here. You see how professional this presentation is actually. So all this presentation I created using the Minimax coding agent. Okay. So here is the Minimax coding agent details. I just wanted to show you, a lot of you had asked that the previously in my Udemy as well. A lot of people had asked, because nowadays almost everyone is doing the AI assisted coding. And if you are not doing the AI assisted coding, then you should start using, but do not be 100% dependent on the coding agent. I would say that start using this so that it can actually expedite your productivity. That's all. Okay. Because now you do not need to write the hello world code by yourself. You just understand the logics, business logics, and the fundamentals, and then use those. Okay. So from that perspective, I can tell you here that if you use this particular link, the link I'll give you here in the chat box here. So this link is going to give you the 12% discount, first thing. The other thing, the usage is really very high. So you can consume like 1.7 billion tokens per month. This is huge. Apart from that, a lot of other things you can do with the Minimax, like you can generate the video, you can generate the audio, music, you can create your own podcast, and you can the post on Facebook channel, or maybe on the Instagram, and so you can create the images with the Minimax coding. And so basically the cloud code and these things does not support the image and music generation and so on. Okay, so this is what you can use, and the presentation which you are currently seeing is created by this. Okay, having said that, let's go ahead and get started with the various kind of the RAG. How many type of RAG we have here in the market, and then I'll tell you why a simple RAG actually works as compared to the complex one. Okay, so you might have heard about the self RAG, corrective RAG, adaptive RAG. If you are getting into the FOMO, don't worry about that. So they are just a name of the RAG. That's all. Okay, so they are just a name. That's all. Corrective RAG. Otherwise, the fundamental concepts behind the scene is going to be the exactly same. That is not gonna change. They are exactly the same. Okay, so what we are going to use here, we are going to use the agentic RAG, although I refer that agentic RAG as the simple RAG as well. Why? Because you see, I'm not using any fancy name here. Why? Because you see, if you try to use the multi-agent system, then they are going to increase your cost, and also they are going to increase the latency as well. So why cost and the latency is important? uh, for us, as you can say that for a testing project or for draft project or POC, it doesn't matter at all. But if you are serving millions of the user, like we had seen at the start of this bootcamp in the Amazon. So if you have something like that related to the if you are trying to build a chatbot like the Amazon, you see there. So the response was really very fast. Okay, how will you use the normal search with dense vector search to get the exact keyword and some other metadata? Yeah, Chitij, I'll come to that part. Don't worry about that. Okay, so these are just the different name. Okay, so what we'll do here, we will just build a very strong ingestion. Once you have ingested your data correctly, thereafter retrieval is going to be super easy. Okay, otherwise, if you don't have a good ingestion, then it is going to suffer badly. So you are going to have your vector DB here. Let's say this is your DB where we have ingested your data. So this is something which we have already seen now. We have understood everything about the ingestion part. Okay. Now in ingestion, two important thing comes in here. So in ingestion, you are going to have two things. You are going to have here the dense embedding, and also you are going to have here the sparse embedding. Okay. So these are the two things which we are going to use here. So in dense embedding, what happened? In dense embedding, you actually project your text data into the vector space. Let's say you have two-dimensional vector representation, V1 and V2. Whatever angle you get here, that is going to be the similarity. So you write it like the cos theta actually. You write it like the cos theta. Okay. So that is going to be the similarity. So you have a V1 and V2. So this theta is going to be the similarity. This is for a dense vector. Okay. So this is for a dense vector. But what you are going to do for the sparse one? So sparse is going to work with the BM25 match. Okay. So the keyword, when you have the keyword or lexical match, at that time you are going to use the sparse embedding. When you have the semantic match, at that time you are going to use the dense embedding. Where we need a keyword match, we need a keyword match like, let's say, some new word comes in where where your LLM or embedding model is not trained to understand its context. Let's say some product code. For example, let's say in the Amazon chatbot itself, if we just type some product code there, then it's very much the possible that embedding model is not trained on that particular product code. So model is not going to understand the product code. So what we'll do here, we will actually use the BM25 match. So that is going to come from the sparse embedding. So you have your dense embedding, you have your sparse embedding. Once you have these, you combine these together, then you are going to get here the reciprocal rank fusion, that is known as RRF. Thereafter, you are going to get your final result. All right, so it is going to come here, the final result. That is actually the RRF, reciprocal rank fusion. It is really important. Once you do all these together, then you are really going to get the very good accuracy. Otherwise, your system is really going to suffer. So how we are going to do in our bootcamp? So this is the overall system which we are going to build. We are going to have here the agent. Okay, we are going to have here the agent, and in that agent we are going to attach get filter context, as I mentioned earlier, that we are going to calculate the metadata from the query so that we can filter out the relevant chunk, and also we are going to search the relevant chunk here. So once we get the filter, for example, we are talking about the Google revenue, then we have to filter first the chunks which is related to the Google. Okay, once we have got that, thereafter we are actually going to search. Once searching is done, thereafter final answer synthesis can be done. Okay, great. So this is the overall thing which we are going to build today. And apart from that, the library which we are going to use today, that is going to be the RagWire. Okay, so the RagWire library we are going to use. This is built for the the production grade RAG system. Why? Because we can actually control our RAG with the configuration itself. So you can just define the config.yaml file, and through this config.yaml file you can control your RAG. And suppose that you are working on a consultancy project for a company X, but tomorrow let's say the company Y comes in and asks you to build a RAG for them as well. So what you have to do, you have to just create another config.yaml file. That's all. You do not need to change the code. You just create another config.yaml file. That's all you have to do. That is why I have been talking about the production grade RAG system. So all these concepts, the hidden concepts, which you generally you do not get from the the books or some the random articles. So these you are gonna get from this particular the bootcamp. Okay, so this RagWire we are gonna use. You can control your the client based on this config.yaml file as well. Apart from that, let me just quickly show you here how you can get started with the RagWire. So here is the link for RagWire. Let me just send it for all of you. Okay, what you guys can do actually, you can just simply click on here. Thereafter, it will lead you to the GitHub. You can just simply start this. Otherwise, if you want to fork this, let's say if you want to contribute in this particular repository, if you find any issue, you want to add here additional feature, anything like that, you can just simply fork it, just create a PR. And then definitely if I find that your PR is good enough, then I will definitely merge that in this particular repository. Apart from that, I guess you must start this repo so that whenever I update it, you should be able to get the latest update. Okay, great. So we are going to use here the Ollama, and in Ollama we will start with the Nemotron 3.5 lightning model, but I'll be also showing you finally with the Qwen 3.8. So Qwen 3.8 is the latest model released by the Alibaba group, and it has been really the very good model. All right, so the setting, getting started with this particular project is really very simple. Just hold on, guys. So I see a lot of people have been joining. Yeah, sorry, Gupta. Yes, you will definitely get the recording of this particular session. Don't worry about that. In fact, let me just share one recording with you guys right now. So I wanted to share that part with you guys so that you can also give a thumbs up here on the recording as well. So if you come here on the KGP Talkie, the channel, I'm just going to give you the link. Just I have one request to you guys. Okay. So here it is. So everyone, could you please just go ahead and, just give a thumbs up to this particular video. That's all I need in this particular bootcamp from you. Just open it on your YouTube and give a thumbs up, or if possible, just give some comment there. It would be really very nice, and it would really, help me. And yes, Kshitij, I ran this Qwen 3.8 on RTX 5090. And if you have seen previously, you might have noticed that here on the kgptalkie.com, I have published this. I have published this full benchmark with the various other models as well, like Nemotron 3.5, Muse Glimmer model, and so on. And this particular article have been really very, very famous article. Even if you search on Google like Qwen 3.8 versus Nemotron, you are definitely going to get this particular article at the top of your search. Okay, so here I have broken down all these things into the pieces. I have explained everything, how it actually work on a consumer grade GPU, and what are the technical aspects which you need to take care while you are working with these small models or local models. Okay, having said that, let's go ahead and come back to the coding part. So here is the notebook, and we are going to first of all use the Langsmith for the traceability and the LLM observability as well. Okay, so here is the environment variable which currently I'm using. This is the Langsmith environment variable. Okay, and the project name is going to be the Finance RAG Bootcamp. That Finance RAG Bootcamp is going to have all the tracing. Let me just quickly show you here the Finance RAG Bootcamp. Once we start working with that, then you are going to get here all the tracing. So it is going to be really very helpful for us to understand how our LLM is behaving, how retrieval is working, and how our agent is actually behaving. Okay, cool. So I hope a lot of things are clear. Now let me just quickly tell you how we are going to use the Qdrant vector DB. So what you have to do, you need to have the Docker. Thereafter, you just need to simply run docker run -d-p and then 6333. That's all you have to do. Thereafter, you will see your Qdrant vector DB is up and running. This is really very simple. And running Qdrant vector DB is super easy actually. You just need to have a Docker and then run this particular command. Then you have your vector DB up and running. And this Qdrant vector DB is actually the production grade vector DB. Okay, having said that, let me just quickly show you how this is running. If you notice here my Docker, so here it is currently running. So you have here a Qdrant vector DB up and running on this particular port. This is currently running locally. Let me just quickly show you where it is. Yeah, here it is actually, in fact. So this is where it is currently running, and collection name is currently Finance RAG Bootcamp. So what we will do once we start the ingestion part, then I will delete this RAG Finance Bootcamp collection for you so that you can understand the overall concept behind the ingestion part. Okay guys, cool. So what we do here, we come back here at the coding part once again. So we are going to load our environment variable here first of all. Okay, so if you are going to get here the true, that means you have already loaded your environment variable in the notebook. And the environment variable currently we are going to load, that is actually just the Langsmith environment variable, so that we can do the tracing here. Okay, so this is something again we have already discussed, how we extract the data from the PDF document. Okay, let's go ahead and do that. Since we have already discussed everything in the detail, so here what I'm going to do here, I'm going to just explain you the code part here. So the fundamental concept is, I guess, clear for everyone. If it is not clear, you can just keep asking here in the chat box. Once this bootcamp the finishes at the 10 p.m. thereafter I'll be talking with all of you personally, so you can ask the question. I would be more than happy to answer your queries. Okay, so we are going to use here the market downloader. So you will notice here this market downloader is getting shipped inside this RAG wire itself. You just need to import this, thereafter load your data, the document. That is going to be the Amazon 10K 24 PDF data. Okay, let's go ahead and run this and then see what you are going to get here. Okay, so this document is actually going to contain all the text data which we have currently here under this particular PDF. So it will take a little bit time. You will notice here it is actually using here some GPU. Seems like CPU utilization is fine, but overall the GPU is getting just used a little bit only. Okay, and finally we have got here the data. Now if you check your doc, you are going to have here a dictionary. So in this dictionary, you are going to have here the text content. Inside this text content, you are going to have whole PDF content. Whatever you have here, whatever content for 89 pages, everything is going to come here inside this. And then you are going to have here the file name, file type, success true, and so on. Okay. And if you just print here some part of the text data, you are going to get it something like this. Okay. So you have the Amazon.com Inc. This is the company name actually. And then form 10K is the type of document which we are currently using in our bootcamp. Okay, great. Now this part is going to be very important. What I'm currently telling you, this is really very important. Okay. Why it is important? Because see, a lot of you have been working in the notebook, but have you ever considered how you need to, how you can create your, the full system along with the notebook? So generally what I do personally, I create my POC and, the initial coding in the notebook. Thereafter, as I see my code is correct and working as intended, thereafter I create .py files. So what I do here actually, so what I'm going to show you here. So I create here scripts, okay, a folder. Then I'm going to create this folder as a module with the init.py. As I create this init.py file, then this become module. Thereafter, I can just simply import this script. Thereafter, what I do here, I create extraction.py file inside this script here. What you see here, extraction.py file. That's all. Okay. Thereafter, I'm just going to create a method PDF to markdown inside this extraction.py. Okay, you will notice here inside extraction.py, just a PDF to markdown. Now the question is here, from where all the codes are coming? So whatever we had seen here, right? So whatever we had seen here, all those are coming from, the code which you had seen in .py file, this code is coming from here. Why? Because I tested this code, it is working fine, it is perfect here. Then now it is time to create it in structured manner. Okay, so I created it in a structured manner and then I put it inside the extraction.py. Okay, now later on, whenever I need to use this particular part of the code again, I can just simply call this particular module, this particular method from the script. That's all I have to do. Okay, let's go ahead and do this. Thereafter, I just simply run this. Now, as we discussed earlier, once you have your text data from the PDF, thereafter it is time to chunk it. So it is time to chunking. So in the chunking, what we are going to do here, we are going to use here page chunking, the page wise chunking. So we use page loader and the page splitter from the Ragwire. Thereafter, we are going to read this Amazon PDF file from here. Then we call this page splitter. And then finally, we are going to split everything. Let's go ahead and run this. Thereafter, you are going to see here 89 pages are going to be there. Okay, so we are going to have here the 89 pages. Okay, great. So we have our 89 pages. Now you can simply check those pages as well if you want to check here. So the page wise, page number 1, page label nothing. Here is the text. This is just first page data. All right. And similarly, page 2, page 3, and page 4, and so on. There are 89 pages. As we discussed earlier, that we have broken down our whole PDF into the pages. Okay, cool. Thereafter, I'm just going to show you here, some page information. Anyway, that is something which we have already seen. Apart from that, I just want to show you here some more information actually. So you will notice here the table of content, and it seems like it is a tabular data or something like that. So as I told you earlier, nowadays LLMs are actually so strong that you really do not need to preserve the table like we used to do a couple of years back. All right, so even if you have running text data, that running text data is going to work as usual without any issue. All right, let me get the hydrated. Okay, so now we tested everything. Once once we learn everything, thereafter what we do here, we are going to simply create here a method. So it is going to be the split pages. Again, this split pages are going to be inside the script here. So you have here the inside the chunking, actually here you have the chunking.py. Okay, so there you have a method like split pages. This is where we are actually using this. Okay, cool. So you have a page loader, page splitter, and thereafter the same code which we had tested, that is actually placed inside that particular script. Why I'm doing this? Because see, as I'm working here with this notebook, I'm trying to create here the production grade kind of the system. Basically, py file which I can later use, okay, directly whenever I try to create, let's say, the UI system. Later on, I'll be doing that using the chainlit. So once I create that UI system, I'll be directly using these py file because I'm testing everything here inside the notebook. Okay, so we talked about the embedding here. Let's go ahead and get the embedding model from the RagWire. And this time what we are going to do, we are going to use the nomic-embed-text embedding. This is really important. I can show you here in the Ollama. So I'm going to search here nomic-embed-text embedding. So here it is. Okay, so you have a nomic-embed-text embedding, and the context window you are going to see here 2000. So as I told you earlier, we always keep context window, the split chunks, the size less than 2000 tokens, that comes from here itself, because the most famous model have a context window of 2000 tokens only. This is the one of the most famous model. 83 million download is done there for this particular model, and this is also very accurate model. Okay, so we are using this nomic-embed-text using the Ollama, and currently I'm running Ollama locally here itself. If anyone of you do not know the Ollama, let me know. We can discuss after the bootcamp about that. Okay, so here we get the embedding. So embedding instance is here. Thereafter, you just need to simply write here embedder.embed query. Once you give your query, thereafter you are going to get your vector. Once you have your vector, then you just need to simply run it. Once you run it, thereafter you are going to get here your vector size. If you want to see how this vector look like, this vector is gonna look like this one. So if you see a vector something like this, then this vector is actually the dense vector. If you remember earlier, we talked about the sparse embedding as well, or sparse vector. Okay, so we talked about the sparse embedding. So that is something we will discuss after some time. But as of now, you have seen how dense vector look like. Okay, but if we talk about the sparse embedding, then sparse vector look like something this, where if you have it, let's say something like this, where you have a mostly zero values. Mostly you are going to have a zero value, and maybe only a couple of values are just going to be filled. That's all. Okay, otherwise mostly you are going to have the zero values only. But in case of the dense vector, you are going to get you are going to see here every value. All right, every value is filled with some value. It is mostly not zero value. Okay, so I'm just going to show you here how actually the similarity is calculated in the RAG system. And if you recall our conversation when I told you how it is calculated with the V1 and V2. Okay, so here two different vectors. So whatever the theta you have here, if you have two similar sentences, then they are going to give you the high similarity. For example, let's say if you have exactly two sentences, then their vector direction is going to be exactly same. So V1 and V2 is going to be exactly the same. Then in that case, you are going to get the zero degree difference. The 0 degree difference means they are going to be cos 0. Cos 0 is going to be exactly the one that is the most similar part. Okay, but if they are not similar, they are dissimilar, then in that case you are going to get it something like this. Maybe you are going to V1 here, you're going to have V1 there, and V2 here. In that case, this theta is going to be very large. If theta is very large, then the cos theta is going to be very low. That means they are not similar. So something like that, we are gonna check here, okay, through the code here. So you see revenue increased during the year, net sales grew over the period. So these two things, what do you think? They are actually the similar, okay? So mostly they are just phrased in a different way, but they seem similar sentence. But what you see here, this one, this is not matching with any of these. So if we compare similarity between these two, we are going to get a high similarity. But if we compare this one with any of these two, then we are going to get a less similarity. Remember, I'm talking about here less similarity. I'm not talking about the dissimilarity, or I'm not talking about the zero similarity. Okay. So because of this issue, what you see here, less similarity, basically there is some kind of always a similarity. So because of this, our RAG system used to hallucinate when we did not had when we did not had the embedding. The filtering one, the metadata filtering actually at that time. So these were the problem. Let me just admit someone is trying to admit in the meeting. Yeah. Okay. So let's go ahead and see how much similarity we are going to have in these vectors. So here you have v1 and v2 and the v3 as we discussed. Now you are going to see v1 and v2. Let's say basically they are two here. Let's say if they are v1 and v2, then you are going to have here how much similarity? It is going to be the 0.73. And this one, which I told you earlier, this one, if you compare with other two, is not matching that much. But even after that, they are actually matching. All right. So although visually, if you see here, this sentence has nothing to do with these two other sentences. Even after that, they are matching. Because of that, the RAG system have been hallucinating previously. Okay. So we need to fix these things. How do we fix this? We fix this using the filtering actually. Okay. So if we use the filtering using the metadata extraction technique, all right. So using the metadata extraction and metadata filtering technique, then we can fix similar, we can fix this. Ideally in production RAG system, what should be happening here? When someone is asking unrelated question, ideally this should be 0 or this should be discarded at all. This should be discarded at all. That's all. That is the ideal situation. That is something which we are going to implement here. Okay, cool. So as we discussed, we will be using here the RAG wire. A lot of stuffs we have discussed till now, that how RAG works, how ingestion works, how retrieval works, and so on. Srikar asking here, do we have dedicated course that covers RAG in depth? Yes, I do have. You can get that from the KGP Talkie. Just see that here, the link at the kgptalkie.com. There you are going to have here the Udemy courses. All right. On this Udemy courses, I'm going to have here, you are going to have here a lot of courses. All right. So you have the RAG related courses, AI related courses, everything here. All right. Deep agent, advanced RAG, fine tuning, and so on. Apart from that, if any one of you are getting confused that how to start with this, how to start with the AI systems and the agentic AI, then here on the learning path, you can click on here the learning path. Then if you are trying to become, if you are trying to master the AI agent, click on here AI agent mastery. Then it is going to take you through the AI agent mastery path. Somehow seems like it's not loading or something like that. Seems like it has overloaded. Everyone is trying to open this. Thank you so much, guys. I need to increase its capacity, seems like. Okay, so you just save this link. I'm just gonna send it. Okay, sometimes breaking system is also good thing, like I'm seeing this. Okay, so here you have your path to AI agent mastery. And here you can see how you can get started with the AI agent mastery part. Okay, having said that, let's come back to the course part. And in meantime, guys, I just wanted you to like this particular video and do some comment on this. I'm just gonna give here once again a link. Please do this for me. And if you have not subscribed this channel, please go ahead and subscribe this channel as well. All right, let's come back to the code part here. So, so we are going to use the RagWire. First of all, what we do here, we load a config file here. Now, this is something which is new to you. And this is again something which I had discussed previously, like maybe 30 minutes back probably. So why we need this config file? Well, config file is going to define the configuration of our RAG system, like what kind of LLM we need to use, what kind of embedding system we need to use, everything at one place. Why it is important, why I'm not putting this in the code? Because as I told you earlier, the reason of this is when I'm trying to replicate a system for a multiple client, then I do not need to copy and paste my code. What I have to do there, I have to just create a different config file. That's all I have to do. All right. Otherwise, everything is going to be exactly the same. So here is the config file which I'm talking about. Okay. The finance RAG YAML file. So inside this finance RAG YAML file, you are going to see here a lot of new stuff. First of all, you are going to see here the loader. So this loader is going to define what kind of file is going to be loaded in the vector database. So if I put here PDF, docx, xlsx, ppt, txt, all these files will be loaded. But let's say if you just want to load the xlsx file, just select xlsx file, only that file will be loaded and every other file will be actually ignored here. With the splitting strategy, we are going to select here the page wise splitting strategy. Although there is a recursive text splitting and the markdown splitting is as well. Markdown is like it is going to split the data on the heading basis. Okay, cool. And embeddings here, in case of the embedding here, if you notice, we are going to use the Ollama embedding. Okay, so we are going to use here the Ollama embedding, and the model which we are going to use here, we are going to use here the nomic-embed-text model, and this is where our Ollama is currently running. Okay, thereafter here we have the LLM. Okay, so in the LLM we are going to have here the provider Ollama, and then we have our seems like someone is trying to join the meeting. Okay, so in the LLM, local Ollama is going to be my, the serving point. Then the Nemotron 3.5 Lightning I'm going to use because it is quite fast actually as compared to Qwen 3.8 and as compared to the Glimmer, Muse Glimmer or Gemma 4 model. Out of all those available model in the range of 30 billion parameter, out of all those models, this Nemotron 3.5 Lightning model is going to be super fast model. Okay, and then we have here the metadata config file. So this metadata config file, what you are currently seeing here, this one is actually going to control what kind of metadata we are going to filter out. Okay, so these are the metadata we are going to filter out from our PDF. For example, company name, document type, and fiscal quarter and the fiscal year. If you notice here, let me just show you here quickly. We had here, I guess the finance RAG bootcamp collection. In that, you are going to have here the company name, document type, fiscal year, and the fiscal quarter. Currently, we are working with the annual document. Because of that, we do not have a fiscal quarter. Otherwise, we have here the fiscal year. Now, this is what going to make your RAG hallucination free. For example, if you select the company name as Amazon, basically you just filter out the document based on the Amazon only, then you are going to get the correct chunk. If you have got the correct chunk, that means you are going to get the correct output. Okay, apart from that, here you see a lot of other metadata. So these metadata which you see here, all these are getting calculated by the RagWire library itself internally. As you see here, you have the chunk ID, chunk hash, content hash, and the file hash, everything. So these hash values which you are currently seeing here, these hash values are getting used to make sure we do not ingest the duplicate content. Okay, so that is why it is really very important. Okay, great. Apart from that, you see the total chunk. How many chunks are there? 89 chunk. And all these stuffs are here. So this is the pre-ingested data. Now what I'm going to do, I'm just going to delete this so that I can show you how we can ingest it from the scratch. So I just delete this. Finance Ragwire Bootcamp is now deleted. Okay. So I just wanted to keep that for your understanding. Once you understand, thereafter we will recreate that. Don't worry about that. So from where that particular name is coming, that name is coming from this finance-rag.yaml file. In that finance-rag.yaml file, I have this finance rag bootcamp. All right. So this is the name here. Okay. As we scroll it down, in JSON dedupe chunk is true. That means chunk basis deduplication can be also done. And here in the retrieval part, we have here the hybrid search. So this is what I had explained you guys earlier, that how this overall hybrid retrieval part is going to work here. Let me just quickly tell you here. Let's say you have your query. Query is going through the embedding model. So there is a two embedding model. One model you have a dense model. Another one you have the sparse model. Dense model is going to utilize here the similarity search. And then this sparse model is going to utilize here BM25, which is the keyword search. Okay. Thereafter, their scores are combined together using RRF. So again, remember this. This can be asked in interview as well if you are a student or if you are trying to switch the job. So this kind of question can be asked, that can you explain the hybrid search? Okay. So this is how you can explain how it works actually. So you have a dense embedding, sparse embedding, then this reciprocal rank fusion works. Thereafter, you get here the final answer. Okay. So this is actually the combined score. So you have here chunks, basically, I'm going to say here retrieved chunk actually. So this is going to be the retrieved chunks, the final retrieved chunks. Okay. If you do not want to use the hybrid, then you can select the similarity MMR or so if you do not want to use the hybrid. But generally, I will prefer to use the hybrid always, because anyway, hybrid is going to beat similarity search any day. Okay. And I'm going to use here the top K4. That means by default, it is going to extract the 4 chunk by default for a particular query. Okay, great. Thereafter, here you see the max content character. Basically, once your agent has got the chunks, thereafter, it is going to start generating the output. Okay, so it is going to start generating output. So I have put here the limit for the output. That limit which I put here, that is going to be the 30,000 tokens. That's all. Okay. Okay, cool. Having said that, let's come back to the coding part once again. Now, guys, if there is any issue with the YAML file, do let me know in the comment here. I mean, in the chat box. I would be definitely addressing that after maybe 30 minutes once this bootcamp ends. Okay, great. Let's go ahead and run this. Now, you will notice this is going to execute. Once this execute, then here if you come and then you see, maybe I need to refresh this collection probably. Yeah, finance RAG bootcamp is appearing here, but there is 0 data point. That means there is no data at all as of now. Okay. Apart from that, you see here cosine. Cosine means it is a dense vector. And then you also see here sparse. Sparse means what is this? Can the similarity and keyword search be? Yeah, Paul, I'll take your question after some time. Okay, so you have here the dense one and then you have the sparse one together. Okay, so dense and sparse is embedded here. Once dense and sparse embedding is embedded, thereafter you can use the hybrid search. Okay, great. Let's come back here. What we are going to do here, we are first going to check our text size. Earlier what we had here, we had total these many characters. Do you recall here in this notebook earlier we had extracted that text data here earlier? Okay, so the same text data we are going to use to get the metadata which we have defined here inside this. Okay, the company name, fiscal year, fiscal quarter, and so on. Okay, so what it is going to do behind the scene, it is going to first of all start my Ollama. Let me just quickly see if Ollama is up and running. Yeah, Ollama is up and running. It would actually start using the GPU. Yeah, GPU is getting loaded here with the model. Okay, so currently I'm using RTX 5090 GPU. It has a 32 GB and here computation has started. Once computation has started, after some time, you are going to get here the output. So this is the first time when it takes a little bit time. After that, it will not take time. First time it took like 33 seconds, but after that you are going to see here, it is going to take just, the few seconds here. Okay. So the clever part is here that we are actually calculating the metadata from the first page only. We are not doing it for all pages. Why? Because let's say if a particular file have 89 pages, then metadata is going to be exactly same for all the pages apart from the page specific data. Page specific data means like the chunk ID and the page number and so. But this data, what you are currently seeing here, this whole data is going to be exactly the same for all pages in a particular file. So that is why I'm gonna use this for a first page only. Okay, so once I get it first time, thereafter what it is going to do, it is going to just reutilize this for all other pages so that we can do our ingestion in a faster way. Okay, great. Let's go ahead and ingest this. So I'm going to ingest this PDF file. You can provide here a list of files as well. So first PDF file I'm going to ingest. Ingestion has started, as you see. First 23 seconds it is going to take to calculate the metadata. That is the most of the time it is gonna take. Thereafter this ingestion is going to super fast. And seems like yes, ingestion has been done here quickly. Okay, so ingestion is done and seems like final verification is being done behind the scene. Once everything is done, thereafter we should be able to see some data here. Okay, now I can see here. Okay, so the Amazon 10K document is ingested and here company name, fiscal quarter, fiscal year, all these data is coming here. Okay, so this metadata is really important for a filtering purpose. Only if you have a proper metadata, only then you can do a proper filtering. Okay, so I guess some of you have sent me a message on email actually. So asking about the Udemy course. Okay, so guys, let me just quickly show you here. So here you have it on KGP Talkie and just come here on the Udemy course page and seems like a lot of you have been using it recently. Because of that seems like server is overloading. Anyway, so this is where you can come. Thereafter you can find out all the courses and here you can find out the AI agent mastery. Don't worry, once we finish this bootcamp, thereafter I'll be also sending out the the email with all other details, also with the resources link, like the repository link, and with the code files and so on. Okay, let's come back here. So we see here ingestion is done for one file. Let's go ahead and see the RAG stat, although we see here everything and here it is coming. So it is ingested inside the finance RAG bootcamp. Total document ingested is here 89. Okay, and vector size is 768. Okay, and this is indexed here. Okay, great. Guys, one more thing actually I wanted to tell you. Currently I am running let me just see here. So I guess currently I'm running a coupon on the Udemy as well. So I guess you can utilize that coupon and that coupon is going to be ended soon. So if you see your price is getting too high in your area, then you can utilize, I guess that is the 18th of August, probably the coupon name. Don't know from where this coupon comes in here. Oh, without login, I can't see any. So in the audience, if anyone of you know the coupon code name, please do let me know here in the chat. If you have seen that, I guess it is 18th August 26 probably the coupon name, which everyone else can use that. Okay, so what I do here, then again, someone is trying to join. Let me just admit that. So our data is ingested here in our vector DB. Now what I'm going to do here, I'm going to ingest this whole directory. Now this is going to be very important. So if you remember previously what I did earlier, actually I copied this Google PDF into a different copy. Now you are going to have here a 3 file total. Okay. So out of these 3 files, only 2 files are going to be ingested. Okay. Yeah. Thanks, Naveen. Okay. Excellent. So I guess there's some coupon as well. I just forgot the coupon name. Probably it was 18 AUG 26. Probably this was the coupon name which you guys can use if in some other country or in some other region, if price is too high. Okay, so this is, I guess, the coupon name. Okay, so you have here the rag.ingest directory data. I'm gonna run this and you will notice only 2 files will be ingested. In fact, only 1 file will be ingested. Why only 1 file? Because 1 file have been already ingested, another 2 files are just a copy. You see? So there are 2 files, only 1 file got processed, 2 file got skipped. Why? This is happening because of our deduplication method here, because of this one. Okay, so it has created actually the hash. It has stored those hash values here. You notice here file hash, chunk ID has, everything, all these hash values. So in runtime, it found out that, okay, hey boss, this is something which is already ingested. So I'm not gonna waste your time. I'm not just gonna re-ingest this everything. Okay, that is why it has actually, rejected everything else. So this is how actually your production grade system should be. If someone brings a file with a different name, you should not be actually ingesting that, right? You should be actually checking each and everything there, that this is genuinely a new file. Okay. Thereafter, if we check here, how many companies data we have with our vector DB. In our vector DB, we have Alphabet Inc. and Amazon.com Inc. file. Thereafter, the document type we have here the 10K and the fiscal year we have 2024. Okay, so these are the data which we have currently in our system. Hypothetically, assume if you want to delete a particular file, you just give a name, it is going to delete. If you want to re-ingest this, then you can just simply re-ingest this one. Yeah, okay, Subramaniam, thank you. So I guess that is the Udemy, the Udemy's own coupon, I guess, probably the coupon which we are seeing there. Okay, so here you see it has started now ingesting and everything is re-ingested here. We have all our data in our vector DB. Once you have everything, now it is time to get started with the hybrid search. So while we ingested our data inside the vector DB, at that time we did the hybrid ingestion, hybrid vector, I'm sorry, not the hybrid, dense embedding, and also the sparse embedding for the hybrid search. Okay, everything is done there automatically. Now I'm going to show you how you can now retrieve from the from your vector DB. Now let me ask here a question. So till now, we did not do anything related to the RAG. RAG means retrieve, augment, and generate. So it is going to be almost 2 hours. Guys, do you recall this? So when we started this bootcamp, at that time I mentioned you that the ingestion part is super important in RAG system. But in RAG system, in its name itself, it has retrieve, augment, and generation. There is nothing related to the ingestion. Okay, and this is where people make a mistake during the ingestion itself. So the ingestion is a prerequisite here. So ingestion took almost 2 hours for us. And we did this ingestion correctly. And it is done in the best way so that we can get the good and a very accurate result. Now we are going to start here the retrieval part. Out of those RAG, R, A, and G, this is the retrieve here, R. Okay. So question is here. So how did AWS perform in 2024? This is related to the Amazon. We did not mention anything related to the Amazon here. You notice here, okay, AWS, we know that this is the Amazon here, okay. Okay, Subramaniam, 18 August 26 is a valid code. Yeah, thank you so much. For anyone else, if they are having this, if they are having high price for the Udemy courses, then they can actually use this particular coupon. All right, everyone. Let's go ahead and run this, how it is going to work. So you notice here, rag.retrieve. Okay. So it is going to give you here all these documents. So all these documents are coming from the Amazon only. Remember, but is it correct? Definitely, it is correct as of now. But until and unless we check inside this, we cannot guarantee that whether it is correct for this particular question or not. Okay. Let's go ahead and see what is inside. So here inside I see organized operations into 3 segments. Seems like answer is coming related to the operations and here AWS. So I feel that answer could be, the chunk, whatever chunk got retrieved here, these chunks could be correct. Okay. So that I'm not here, arguing here. That is something which we will check later on once our agent will start generating the final answer. So as of now, we see that it is giving us the result. Okay, great. Now this part is going to be the super important here. So I ask here a question, how did Apple perform in 2024? We got the output, but we do not have the Apple data at all. We have the data for the Amazon and the Google only. Even after that, we are getting data here. So this is why we need the filtering. If you do not do the filtering, if you do not do the metadata filtering, you are going to get the output something like this. Now just hypothetically assume if you give a question this and context this to your small language model, then your language model is definitely going to be confused there. So it will just mix up everything together and then very confidently it is just going to give you the final answer, which has nothing to do with the Apple. Okay, because of this we need the filtering. Hypothetically assume if we could have filtered it using the company name which we have here, probably in the last or somewhere we must be having that actually. So if we filter it using the metadata like a file name and the company name and all these things must be here. Metadata, yeah, here it is. Okay, so the company name and the document type. So if we could have filtered it out using the company name itself, then you see here it would have been, the super accurate. Basically we must have got here the 0 result actually in that case, because we don't have any data related to the Apple. Because of that we actually need the filtering. Let's go ahead and do here a manual filtering. Later on we will do this filtering using the agent itself. So we do here a manual filtering, filter company name Alphabet Inc, and this time I'm asking question related to the Google, and let's go ahead and do this. And now we are going to get here everything related to the Google only. Okay, cool. Let's go ahead and ask about the Facebook here. So if we do it like this, extract filter first of all, so it is going to get the filter for this particular query. So what kind of filter it is going to use? This is really important here. So you will notice in the filter, it is going to have the meta related company name. Okay. And we already know that we do not have any data related to the meta. That means related to the Facebook. Okay. So here company is Meta fiscal year 2024. Now, if we come back here and if we try to use this filter for any query, then definitely it is not going to give us the answer. Okay, great. So I guess I asked question related to the alphabet only. Let's go ahead and put this here. I guess we put the filter using the dictionary only. Okay, here it is. Let's say I ask about the Facebook here. So it is going to give us the 0 result. There is nothing. Why? Because we don't have the data. So this is why I told you earlier, you need a metadata filtering for a hallucination free RAG system. Let's go ahead and see how the answer is grounded. So this RagWire library have an inbuilt agentic AI system inside it. A simple RAG, agent is already inside the RagWire. So if you do not want to build the external agent, then you can just simply use the rag.query. It is automatically going to utilize the internal RAG, internal agentic system. So it is going to use the LLM internally, the agent internally for this query. What was Amazon's total net sales in 2024? Let's go ahead and check this, how it is going to work. So it is going to perform the retrieve. It is going to perform the, the final answer, something like this. You see, it has quickly retrieved the answer, and thereafter it has immediately generated here the final answer here. Okay. Yes, Aditya, I'll share this code. Don't worry about that. One session is finished. Thereafter, I'll be sending the code files and the presentation, everything. Don't worry about that. Okay, great. So it is done. Let's come back here and check the citation. So citation is this one. It is coming from this particular, source here. Yes, Ravi Kumar. Yes, it is allowed to use in any company. It's completely open source. Okay, and yes, it is available on the GitHub. Don't worry about that. I'll be also giving the link, when I'll be sharing all the detail after the bootcamp. But anyway, you can come here. So here it is. I'm just going to paste it here inside the chat so that you guys can have this. Okay. As I told you guys earlier, you just need to come here on the GitHub and make sure you star this. And if you want to contribute in this particular repository, just go ahead and fork it and thereafter do the contribution here as well. Okay, great. Now let's go ahead and see what kind of guardrails are made there. If you ask a question related to something which is not already available inside the RagWire system, then it is going to refuse here. So refuse is true. Why? Because Apple data is not present. Because of that, it says refuse is true. If you check here the data, it says that I do not have enough information. Okay, great. So this is, we have been till now talking about the RagWire library and the agentic system inside the RagWire. Suppose that you want to build your own agentic system and you want to utilize only the ingestion and the retrieval part of the RagWire so that you can have a full freedom on the system implementation. Then you can use your own system here. So this is how we are going to build. So what you have to do, you have to utilize two methods. So one is get filter and the search document. So these are the two methods. This one is going to get the filter context from the search query. Thereafter, this one is going to retrieve the document from the vector database. Okay, let's go ahead and build these two. So they are really simple. rag.getFilter context you just need to do. And in search document, you just need to use the rag.retrieve. This is something which we have already used. If there is no result, just say that we could not find any result. Thereafter, once we get the result is going to be here a list. Okay, since it is a retrieve, like we had seen, it is going to be the list of the document. And then inside the list of document, we are going to get here the source so that we can do the citation properly. Okay, and then we are just going to merge the source page number along with the content so that LLM can understand when it is LLM can cite the answer when it is trying to generate the final answer. That's all we have to do. Let's run this. Thereafter, we are just going to actually store all these things which you are currently seeing here, everything inside the scripts.tool. Okay, so if you notice here, scripts.tools, here it is going to have the get filter context and search document, everything there. Okay, so this is what I have been talking earlier as well. While we are working in this notebook, we are also making sure we store all these modules inside a script. Okay, great. Let's run this. Thereafter, what we do here, we actually get our model for Nemotron 3.5 Lightning. It is running locally on my Ollama. Thereafter, I'm also going to use here the in-memory saver as well so that I can preserve the chat histories as well. Again, as you know, there are various kind of memory in the agentic AI system. You have the short-term memory, you have a long-term memory, and in meantime, any one of you are wondering that you do not know the LangChain, how to get started with the LangChain, I will tell you, I have recently published a 10 days LangChain bootcamp on the YouTube. So you can go ahead and get started with this particular bootcamp. This is really a very good bootcamp where I have covered everything related to the LangChain. Okay, so let me just quickly give you here the link in the chat. And guys, I would suggest you go ahead and save this so that you do not miss this link. You go ahead and just save this here from here so that it can be saved in your YouTube watch list as well. Okay, great. Let's come back here. So what we do here, we have our check pointer, memory saver we are going to use here. Not the in memory. In fact, we are going to use here the SQLite so that we can actually store our chat history in SQLite here. Inside a DB directory, we are going to create here a DB directory, and this is where we are going to store it. Okay. And then we are going to create our own agent. Earlier, I told you whatever agent we used with the rack.query, that agent was actually built inside the RagWire itself. Now we are going to use here the external tools with our own agent. Those external tools are going to be get filter context and the search document. And this is going to be our own system prompt. Now it is up to you how you want to modify your system prompt. You can really create a good system prompt which can give you a good citation and good reflection on your final answer. So these things you can work on system prompt. Thereafter, we are going to pass here the check pointer. So this check pointer is going to be passed. This is the SQLite. Once that is done, thereafter we are going to create here the config. So it is going to be the configurable thread ID class demo. Okay, let's go ahead and run this. Once you run this, thereafter you will notice DB is created here. Once you have got here the DB, that means inside this DB you are going to have agent memory.db. Okay, so currently we do not have anything here because we did not store anything here. Okay, great. Let's come back here, and thereafter what we are going to do here, we are going to stream the result. So this is again very important. So we know the result comes in two forms from the AI. Either you get the whole answer in one go, or you get the answer one by one. Okay, so if we talk about as tokens or as chunks are getting generated, then we are talking about the streaming. So your LLM actually stream the result. Okay, whenever you do the chatting with the ChatGPT or Claude or any local LLM, you see they are generating the result of the token by token. Okay, so if you do the streaming, then we can see here the result as well in that particular form, like the token by token. So we use here agent.stream instead of using agent.invoke. We are using here agent.stream, and stream mode is going to be updates here. So as it is going to update the states of the agent, it is going to stream the result back to us. Okay, so in that update, it is going to give us the various messages. So what are those messages going to be? Let me just quickly tell you here. So there is going to be, select it here. There is going to be various kind of messages. So you might have heard about the AI message. Okay, you might have heard about the human message. Then there is the tool message. So what happens generally in AI message, actually, AI message can go in two ways. So AI message can give you the final answer. Otherwise, AI message can do the tool call. If AI message do the tool call, if it is doing the tool call, then there is going to be the another message, that is the tool message. If tool call has happened, tool need to return the result. Return result is going to be as the tool message. Okay, so this AI message can follow two paths. Either it can follow the tool message path, or it can follow the direct answer. So if AI message have a tool call, that means it is going to also have the tool call, tool message as well. So this is what we are checking here, if you notice. Okay, so if AI message, if a message type is AI, and also there is a tool call, basically this particular path we are talking about. If it is AI message and if there is a tool call, then we need to print the tool call name as well. So basically what particular tool have been called here. And thereafter, if message is a tool, that means it is going to be the tool message. Okay, so if message is a tool there, then it is going to be the tool message. That means it is a tool result data. And if there is AI message and there is a content in the AI message, that means AI is following this path. This path means there is no tool message. Okay, so I hope this particular part is clear to everyone, right guys? So give a thumbs up if this path which I just explained you, how this AI and the tool message and the tool call works, please give a thumbs up that it is clear to you that how it works. Okay, great. So once that is done, then what we do, we just simply run it. Then we come back here. One more thing I should tell you here, I have stored this inside the agent.py. So that is currently here inside the agent.py. It is stored here. Okay. So as I have been telling you earlier, whatever code I'm writing here, as I see my code is good, that code is getting stored inside the scripts in the form of .py file. Okay, great. Thereafter, what I do here, I import this stream agent, which I just stored inside the agent.py. So once I do this one stream agent, okay, then I'm going to stream the result for my query. So query is like, what was Google's advertising revenue in 2024? So it is going to be like this one here. Okay, so it is going to take a little bit time, and thereafter you will notice tool call has happened, get filter context, and then queries Google advertising revenue 2024, and here is the filter context, and then finally answer is coming here. So you will see answer is this one. Okay, so this whole thing what you are seeing here after this answer, what you are seeing here, this is actually answer. Okay, so here Google's advertising revenue is this, and then finally you are going to have here the source, that is the citation, basically from where this particular answer is coming. Okay, great. Let's go ahead and check the another question here, like how does that compare with the Amazon's total revenue? So you see, this is important. We did not discuss anything about the Google in this particular thread, since we are doing here, we are also storing the chat histories as well. Because of that, it is automatically going to refer the Google's revenue previously, and then it is going to finally compare the Google revenue and the Amazon revenue. And this is the answer. After this answer, what you see here, this is the final answer coming here. So here Alphabet advertising revenue, and here you have the Google revenue. Okay, and this is how it is getting compared together. Okay, great. Apart from that, if you come back here inside this .dv, and then inside this .dv, you are going to see here. Okay, so everything is written here. That means our chat histories got stored here locally inside this SQLite. Now you can just simply, take this .db anywhere else, your chat histories are going to be preserved. Okay, great. Let's go ahead and ask the another question. So this time, which company's collection had the highest total revenue? This time, you see the answer is very fast. Why? Because the answer was already present in the history. Okay, great. And then finally, we have here all the states. And once I finish this notebook, thereafter you will notice, one thing I guess should tell you, once I finish this notebook, thereafter I'll be also showing you how you can have a full-fledged UI system as well, where I'll be showing you how you can build it using the Chainlit. And then we will be utilizing all these scripts as well. Okay, great. So stay tuned for 10 and 15 minutes more, everyone. So we are just going to finish this. I see a lot of people have started dropping out because anyway, we are past 10 by 7-10 minutes. Okay, so you see, this is how this chat histories are going to be maintained. All right. Okay, so this is something which is clear, everyone. Okay, as I promised to you, in 5 minutes, I'm just gonna, finish everything. We are done with this notebook. One thing you must have noticed here, whatever we did here, everything we stored inside this scripts.py. This is the important part. Whenever you are actually doing the POC for your project, you are testing your concepts, then always create a scripts and store your matured Python method inside the directory so that you can use that later on. I'm just gonna show you here. Okay, so you notice here I created this app.py file. Inside this app.py file, you will notice everything whatever you are seeing here. This is what we have already seen. So this is actually the Chainlit file. Okay, so I just import Chainlit as a CL. Thereafter, this is a standard. And then this is again the standard which we have already seen, you see. Thereafter, you are just going to see here, this one is again the standard part. What you are seeing here new, this is something which is you are seeing in new. Okay, out of this, let me just run this. Thereafter, you will see its miracle. Okay, so it is going to be this one. UV run chainlit run app.py. Okay, so I run here UV run chainlit run app.py. Okay, so it is going to run here a UV. It is going to run here a Chainlit server, and then we will be able to chat with our with our RAG system, which we just built. Okay, it is taking a little bit time. Yeah, it has started here. And yes, it has started on localhost at a localhost port number 8000. So I'm going to show you here as you see. Okay, great. Now I can just ask here a simple question like, what is revenue of Google? Let's say from Europe, probably. Okay, we can ask from China as well, or India, USA, or whatever. The most of revenue comes from the, I guess, the US and the Europe only. So it has started working behind the scene. As you see here, GPU consumption has gone up. That means it has started working. And now you can see here the final output probably. Yeah, here it is. Okay. So you have got the final output and everything as it is working. So let me tell you here how much time we actually took to build this app.py. Okay, so I explained you like in couple of minutes, but you might think that, okay, I have already written this. That is why I could explain you. But honestly, if you notice here, this is the only method which I had actually written. Everything else is coming from scripts.py, which we have already seen. Now, hypothetically, just assume if we do not have this one, then all codes are inside the notebook, then that is useless for this application. Okay, that is why I told you, why while you start working, I mean while you are working with your project, whenever you feel that you have a good method with you, just store that somewhere in .py file so that you can use that later on. Okay, so you will notice here I'm using the stream agent from this scripts.py itself, and everything else is also getting used from this scripts.py itself. Okay, and here just this part is actually written here, that's all. And now we have here full-fledged UI system which is currently working. Okay, and then similarly we can ask other related question, whatever basically the question you want to ask, you can ask here. Okay, so I hope it was helpful to you guys, and this repository I'll share with you over the email once we finish this bootcamp. And I guess that's all from my side. And if you guys have any question, any doubt, please ask that here itself. And in last, I just want to tell you again, and if you haven't, if you have not liked this particular video, please go ahead and like it. And if possible, please do, share some comment on this video as well. Please don't forget about that. Apart from that, for all other people who are getting started with the LangChain, go ahead and save this particular playlist. In this playlist, I have actually um, talked about the 10 days bootcamp from the very beginning of the LangChain to till the end of the LangChain actually. So basically, I have talked about everything like how to use the free AI API services, and then tools, memory, LangChain, everything actually. So you see from day 0 to day 10 actually. This is really going to be very a very good playlist. All right, everyone. And now I guess we are open for the question. And if you have any doubt, anything else you want to ask, you can definitely ask that. And for all other people who want to leave, they can leave. There is, I mean,